questions from homeworks? Is that because it was easy or because we haven't started yet? Okay. I heard one easy. I'll take it. When you get the answer you're looking for, stop asking. Cheyenne.
I gotta get the one pull up. You said to do worksheet 3, I think. There was some stuff on
Okay.
I don't really remember.
Yeah, the first page, we'll talk about how to do that today.
Okay.
Yep, that was my fault.
It was like the frequency stuff.
Yep, that's my fault. We'll talk about how to do all that stuff today. Huh? Ooh, look at you, show off.
I know. I'm basically maxing.
Pretty cool. All right. All right. So last time we talked about for the fundamental functions for sine and cosine. We talked about the midline that was at y equals 0. Talked about the period, which was 2 pi. Talked about the amplitude, which was 1. And we talked about the frequency, which was 1 over 2 pi. Right? That all hopefully looks familiar at least. The other thing we did yesterday, or last time, I keep saying yesterday, is we talked about how to graph and describe the transformations to sine and cosine. What I want to talk about here to start with is how these transformations affect the locations for the midline, the length of the period, the size of the amplitude, the frequency, etc. So we have the midline. We'll start there. Remember, the midline was the the horizontal line that divided our graph in half. Which type of transformation, an A, C, H, or K, is going to affect the midline? Exactly. A vertical shift up or down will change the location of the midline because it's just picking up all the points and moving them all up or down, right? The midline, or the K, represented the vertical shift. So the midline in a transformation will just be y equals k. All right, let's talk about the period. Remember, the period was the horizontal length of the longest non-repeating section of our graph. What type of transformation will change the period? So it was the horizontal distance or length of the longest non-repeating section of the graph. Oh, so a horizontal stretch or shrink will affect the period. That was represented by C. But remember, C could also affect a reflection if it was negative. So we're just going to use the absolute value of C. Or you could think about the period being a length, and it doesn't make sense to have a negative length, right? Even though C could have negative values. So we'll just take the absolute value of it. Great. Remember, the amplitude was a distance from an extrema, a max or a min, back to the midline. What type of transformation will affect that? So that's a vertical distance, right? From an extrema back to the midline. So a vertical stretch or shrink would affect that. The vertical stretch or shrink is controlled by A. Again, A can have positive or negative values, but the amplitude's a length or a distance. So we'll just take the absolute value there. And the frequency was just 1 over the period. So there we go. Everybody's cool with that? Okay, let's do a quick example here. Let's say we have the function y equals -3 cosine of 2x plus 6 minus 4. And we want to find the values for the midline, the period, the frequency, the amplitude, all those good guys there. So my first order of business would be to write it into this transform or the general form for a transformation. So that's going to be -3 times cosine. And then what do I need to do then? This is the tricky part, right? Making this look like that. Great, start by factoring off a 2. Okay, but that's not, still got a little bit more to do, because right now I should be writing that as 1 over c, and it's 2. And it should be written as a subtraction problem. I have an addition problem. So how do I fix the 2 part? How do I write 2 as a unit fraction? Right, as 1 over 1/2. Right, the reciprocal of the reciprocal is the same as doing nothing at all. So just write it as the reciprocal of 2. And then how do I rewrite plus or an addition problem as a subtraction problem? Great, minus a negative. So then it should be easy to see that my a is -3, my c is 1/2, my h is -3, and my k is -4. Cool with that? Just like we did in the previous homework sets, finding those values, still the same process. The midline we know is y equals k. So in this case, my midline should be y equals -4. Now, Mr. Kulik's word of warning here, I am going to be picky about how you're writing your midline. If you do not write y equals, I'm not going to give you full marks for it. If you just write -4 as the midline, I'm going to mark that wrong, because the midline is an equation for a line, not a number, right? It's not a length or a distance or something. It's an equation for a line, so it has to start y equals. Okay, that's a warning right there. The period we said is 2 pi times the absolute value of c. So what is my period going to be in this one? Two pi times 1/2 is? You don't need a calculator. Pi. Excellent. And then the amplitude was the absolute value of A. And the A in our case was -3. So my amplitude is 3. And then the frequency, how do I find the frequency? Just 1 over the period. So 1 over pi. What do you guys think? Pretty easy, right? No big deal. We're just filling some stuff into some formulas, which you should be saying, yeah, right on. I can fill some stuff into some formulas. Although getting ready for the test, what would Mr. Kulik suggest here? These guys ought to go on your note card, right? You'll definitely want to have that information. One less thing to have to memorize, right? It's the goal of the note card should be to eliminate your memorization. You know, and worry about doing the stuff, not memorizing junk. It's not junk, but you know what I mean. Okay. The next type of problem we're going to talk about is going to be going from a picture of the graph back to an equation. So let's look at an example here. Do it this way. It gives me the best outcome. All right. So here's my graph. I want to be able to write an equation for this. Now, if you remember back to last time when we looked at the graphs of sine and cosine, they're basically the same picture, just shifted left or right. Everybody agree with that? That tells me that any sinusoid, any of these wavy graphs, could be written as both a cosine function or also as a sine function. It doesn't really matter. I can do it with both. Everybody agree with that? So there's at least going to be 2 answers for this, one with a sine and one with a cosine. Everybody agree with that? And because the graph repeats, it's periodic. If I find one answer, if I shift it 1 period to the right or to the left, that's also going to be an answer. Everybody agree? That would give me the same picture. So really, we don't have 2 answers. We have infinitely many answers, because any translation left or right by a period to a correct answer will also be a correct answer. So there's infinitely many answers to this. Does that mean that anything is an answer? No. But once you have a correct one, you can generate infinitely many other correct ones just by shifting. Okay? All right. So our goal is going to be to write a oops, let's do that right. Yes. An equation like this, or an equation like this. Okay? We're going to write both answers for the examples that we do, just so you can see how to do it both ways. Everybody's cool? So to fill this in, I need to figure out values for A, C, H, and K. Does that sound good? Good, I agree. To do that, what am I going to use? I'm going to use those properties of sinusoids that we just got done talking about. The midline, the period, the frequency, well, not the frequency, the amplitude, Those will all help me find the values for A, C, H, and K. Everybody cool with that? I like to start by looking for the midline. Does anybody see where the midline is just by looking at our picture here? The x-axis, right? Y equals 0. Everybody agree with that? Where I have the same amount of graph above as I do below. And since the midline is y equals k, that tells me that the k is 0. Sound good to you guys? All right. Let's find the amplitude next. In words, what is the amplitude? It's the distance between an extrema and the midline, right? So maybe let's look at the distance between this maximum and the midline. How far is that? 2 units. Remember that the amplitude is the absolute value of A, so this tells me that A is 2 or -2. We'll have to figure that out a little bit later. Good with that? Okay. The next thing we're going to look at is the period. The period is, in words, the horizontal length of the longest non-repeating section of our graph. Well, if I look at our picture, the entire thing is a non-repeating section. Everybody agree? Where I have an up, and then I have a down, and then at the very end, I'd be starting my next up again. So this entire thing is one period. Everybody's okay with that? If I look at my graph, every tick mark appears to be pi over 2 units. So that means that this piece over here is negative pi over 2. That one there is positive pi over 2. So how far is that period if it's going from -2 all the way to +2? 4, and then we'll just tack the pi on at the end. So 4 pi is the length of our period. Everybody's cool with that? And remember, we find a period by doing 2 pi times the absolute value of c. So if I divide both sides by 2 pi, I get that the absolute value of c is 2, or that c is 2, or -2. The frequency is not going to tell me anything. It's difficult to pull a frequency from a picture, and it doesn't tell me anything more than the period would. So in terms of A, C, H, and K. So we know K for sure, right? That's for sure. The A and the C, we've got it narrowed down to 2 numbers. But we can actually do a little bit better than that even. So it turns out that you can really do the same thing with the negative signs on A and C as you can with a translation, a horizontal translation. what that really boils down to is we can always pick either A or C to be positive and still get a correct answer, and that'll help streamline our process tremendously. My suggestion to you is let's always pick C to be positive, and then depending on how we find our H, we'll decide whether A needs to be positive or negative, but we can always assume C is going to be positive. Now, everything we've done here applies to a sine graph or a cosine graph. None of this will change. The piece that will change is figuring out which sign I want on A and the value of H. So those two things are related. Those are the two things we still are left to figure out. So let's see how we do that. Let's do the sine one first. The way we're going to do that is we're going to use our transformation map, the same thing that we used for graphing. So remember when we graphed one of these transformations, we took points from the parent function, we plugged them into our function map to get the point for the resultant function, right? So we'll start by choosing a point from our parent function. Since we're using sine, we'd pick one of the reference points from sine. Which point would I want to use, do you think? There's an answer that's easier, although it doesn't really matter, but like my life's hard enough, I want to do it the easy way. 0, 0 would be the type of point that I'd want to pick. Great. And notice here that we have two different kinds of points in our parent function. So we have points that lie on the midline, and then we have points that are extrema, either maxes or mins. Everybody's okay with that? So here we're going to choose from the parent function the point 0, 0, which we said was a midline point. And now I'm going to choose from my graph another midline point. So if I look, I have 3 midline points to choose from: negative 2 pi 0, 0, 0, and positive 2 pi 0. Which one of those would you like to choose? Doesn't really matter. Any of them will work. You give Mr. Kulik his choice, he's picking 0, 0, just because zeros are easy to work with. Everybody's okay with that? We have to be a little bit careful here, because it turns out these midline points, there's actually 2 different types of midline points. So if I go back to my parent function, notice I'm going from a midline point here to a maximum is the first extrema after that midline point. Everybody's okay with that? You can tell it's a maximum because the y-coordinate is the biggest, right? If I go look at my picture now, what is the extreme point after 0, 0? That's a minimum. So I'm just going to add a little notation here. So in the parent function, I had a midline point, and then after that was a maximum. I'm going to do an up arrow to represent a maximum. In my picture from the midline point 0, 0, I go the next extreme as a minimum. To represent that, I'm going to use a down arrow. Is everybody okay with the notation that I'm using there? This is how I'm going to use, or this is the information I'm going to use to decide the value for A. Because these are opposite, that's going to tell me that the A is negative. So we're going to use -2. One thing left to find, that's H. So remember, when we're graphing one of these, what we do is we take like the x coordinate, we plug it into cx plus h, and that's going to give me the new x coordinate. Everybody's okay with that? So if I follow that, I'd have c times 0 plus h should equal 0. What's c times 0? 0. What's 0 plus h? H. So I'm left with just h is equal to 0. So one possible answer would be that. Is everybody okay with what I did there? Let's show you guys how this changes a little bit if I decided to use a cosine function instead of a sine function. So we still have the same problem here. We need to figure out whether the A is going to be positive or negative, and we need the value for H. So just like before, the tool I'm going to use to do this is going to be that transformation map that we use when we're graphing. This time, since we're using a cosine function, the point from the parent function we have to pick has to come from the cosine points. Which of those points looks like the one that Mr. Kulik would want to pick? Any of them are okay, but like there's one that makes life easy. 0, 1. Observe, what kind of point is 0, 1? Look at the y-coordinates. It's a maximum, right? If I look at the y-coordinate, it has the biggest y-coordinate of all the points on the parent function for cosine. Tells me it's a maximum. So what I need to do now is I need to go back to my graph and I need to pick an extreme point. It doesn't matter which extreme point I pick. I see two of them. I see a maximum here at negative pi comma 2. And I see a minimum there at positive pi comma negative 2. Doesn't matter which one you pick. Anybody have a preference? I don't know, let's just pick the first one. Sound good to you guys? And I'm going to note that that was also a maximum. So what I observe here is that I'm pairing a maximum with a maximum. That's great. That tells me that the value for A must be positive. So my A here should be positive 2. And just like before, to find my value for H now, I'm going to take the x-coordinate from the parent function, plug that into my transformation map, and that has to equal the x-coordinate from the transformed function. C times 0 is 0. 0 plus h is h. So I end up with just h is equal to negative pi. And there's everything I need. What do you guys think so far? It'll take a little bit of practice, but there's nothing like computationally difficult about what we're doing. You have to understand what you're doing for the process to make sense, but the process itself, at no point did we do any sneaky algebra. We're just kind of looking at pictures and using some formulas, and should be relatively okay. Yeah, that doesn't look good at all. It's because I didn't do this because I was a dummy. There we go. All right. Let's do one more example and then we'll be done for today. How's that sound? I think Luke's done already. I'm just teasing you, Luke. All right. What do we start by finding first? Midline. Great. Where's the midline at? Y equals 1. What does the midline tell me? The value for K. Everybody cool? Next thing we look for is the amplitude. The amplitude is the distance from an extrema to the midline. What's the amplitude here? No, we drew that in ourselves. So that's our amplitude, right? How long is that? 1. So that tells me that the A is 1 or negative 1. Is everybody okay there? Third thing we find is the period. How long is the period here? So I would be counting either from I like to go from either max to max or min to min in a problem like this where I have lots of periods, because I'm not going to goof that up. Sometimes if you're looking at midline point to midline point, it's hard to tell. So maybe I'll go from this maximum over to this maximum. That's one period. How long is that if we started at 0 and we ended at pi? Pi. 1 pi. Everybody's okay with that? And I know a period is 2 pi times the absolute value of c. So if I divide both sides by 2 pi, c is either 1/2 or negative 1/2. And we can always choose c to be positive. That's what I'm going to do here. Mr. Kulik would always make that choice. Everybody's doing okay? All right. So let's do the sine graph now. We've gotten all the stuff that's we can until we pick which kind of function we want to work with. So from the parent function, we're going to pick the point 0, 0, which is a midline point followed by a maximum. Mr. Kulik will always use that for a sine graph on these types of problems. And now I have to go to my picture and find some other midline point. So any point where the graph crosses the midline would be okay to use here. We have lots of choices. Does it really matter which one we choose? No. Mr. Kulik's going to pick this one, which is pi over 4, comma 1. And that's a midline point that's followed by a minimum. Everybody's okay with that? If I compare the type of midline point we have, what is that going to tell me? The A is negative because they're opposite types of midline points. And when I plug 0 into cx plus h and set that equal to pi over 4, I get that h is just equal to pi over 4. And that's now everything I need. Oops. Let's do the cosine. From the parent function, we're going to use the point 0, 1, which was a maximum. We're going to pair that to some other extreme point from my resultant function. Any extreme point will do. We have lots and lots and lots and lots of choices. So any of those maxes or mins are fine. Which one do you suppose Mr. Kulik's going to pick? I'll pick that one, just because the numbers are small. That's the 0.02, which was a maximum. Because they're both maxima, what does that tell me? It tells me A is positive. And then what do? I plug 0 into Cx plus H and set that equal to 0 to solve for H, which is just 0. And now I have everything I need. Is everybody okay with that? That's it. That's the gist of it. That's all we're going to talk about today. Next time we talk, we're going to talk about going from a description of the graph, so partial information about what's going on, and writing the equation from that. Your guys' homework, you guys can now do, let's see, 1 through 6. Nope, 1 through 8. You can do the rest of worksheet. Which one was that, Cheyenne? 3? And we can do worksheet 5. We haven't assigned worksheet 4 yet. We're not going to do worksheet 2. These are same things as in worksheet 1. I didn't feel like we needed to do that practice twice. You guys seemed pretty good with it. Is you're graphing this. So you're using the parent function, the transformations, just like we did in the notes. Yeah. So just like we did here in this example, Cheyenne. You may go.
I just have to get eye drops as well.
Yeah, that's okay. That's okay. You can get your eye drops. Sure. Cheyenne, that's all. You're doing that process. Okay, you said some words, but it was kind of quiet and you're far away and other people were talking, so I couldn't really understand what you said. I'm not trying to be obtuse, but it's okay? Okay. We'll stop here.